Humanity sends increasingly advanced robotic explorers to Mars. However, despite significant advances in miniaturization, it is not still possible to send the best instruments to Mars because of their mass or dimensions. Therefore, in order to be able to examine samples from Mars in greater detail, experts from the USA and Europe have prepared an extremely ambitious chain of missions called Mars Sample Return, or MSR for short. The first link in the entire chain is the Perseverance rover. It has been operating in the Martian Jezero crater for almost 2 years, and if it encounters a rock of scientific interest, it can drill it and extract a sample from it. There was a lake in this crater in the distant past, and the rover operates in places where we would have found a river delta millions of years ago. In theory, local deposits could contain traces of life. The rover extracted 2 samples from each drilled stone. It stores each acquired sample in a hermetically sealed tube. At the beginning of this year, it unloaded 1 sample from each pair, one by one at one place. The second sample of each pair still remains inside the rover. So there are 10 tubes with samples on the surface of Mars, and another 10 are still carried by the rover. In a few years, a lander is to land on Mars, another part of the MSR program. If the Perseverance rover is still operational at that time, it will bring the samples to the lander. Otherwise, 2 small, Ingenuity-like helicopters would be used to deliver sample tubes stored on the surface. The next procedures will be same in both cases. The lander will be equipped with a special, very agile robotic arm provided by the European Space Agency. The arm will carefully grab each sample tube and store them one by one into a container in an approximately 2 meters long rocket that will be placed on the lander. Once all the sample tubes are in place, the container will be closed. The lander will launch the rocket into the air, and when the rocket is at its highest point, it will ignite its engine. This will ensure that the lander will not be tipped over due to the exhaust gases from the rocket engine. The 2-stage rocket will deliver the container with the tubes into Mars orbit, where it will be intercepted by a European satellite. Its first task will be storing the container with samples in a return case. After that, the satellite will depart to Earth. If everything goes well, the samples should arrive to Earth around 2033. Scientists will then have a unique opportunity to study the ancient history of Mars and perhaps even find an answer to the question of whether there was ever life on the Red Planet. After a successful simulation of pre-launch activities, Starship 24 was removed from the Super Heavy booster and taken outside the test area. Specialists have to remove mounts for connecting to the crane and replace them with thermal protection tiles. In the meantime, the Super Heavy is currently undergoing preparations for the static fire of all its engines, which could come as early as this week. Relativity Space have shown a short footage of a combustion chamber test of their new Ion R engine. These engines are expected to be placed on the future reusable 3D printed Terran R launcher. Thank you for watching Spaceflight News. Our show is also on Twitter. Just click on the link in the video description. You will not only be informed about our new episodes, but you will also learn about other news from spaceflight.